Hi everyone. Let's to talk about improper integrals. Sometimes you have the definite integral has a limit infinity or minus infinity, or both limits are minus infinity and positive infinity. This is the type 1 of the improper integral. There is another type of improper integral when the function itself is infinity inside the interval of the integration. So let us consider the first type, which have infinity in one of its limit. Now, how I can do this one? I can do this one by replacing the infinity by any symbol, and after I finish integration, I take the limit for this symbol into positive infinity if I replace it by the positive infinity. So, when to integrate 1 over x squared from 1 to infinity, I know the integration of 1 over x squared is minus 1 over x. So I substituted by b, so I have minus 1 over b. Minus minus will be plus 1 over 1. So after taking the limit for b tends to infinity, 1 over infinity is 0, so I have 1. So this improper integral value is 1. Yep, here is another one. So as you said, I have a problem in this case. If I replace x by 0, I have the integrand itself, or the function you're integrating, is undefined in this interval 0 to infinity. So in this time, yep, I can have the problem. I can replace the 0 in this case by another symbol, s for example, and I take the limit when s tends to 0 from the right side. Okay, because I can't go from the left side because I have root square x here. If I go from the left hand side, I have undefined value. Okay, so this is the easy way. This is the second example, is the second type of improper integral. But in this lecture, we are concentrating or focusing on only the improper integral of the first type. Here it is. If you have such one, yes, you replace the infinity by another symbol, b, and then I integrate normally and substitute, and then I take the limit for b when b tends to infinity, because I replace infinity by b. In the second one, also, I replace the infinity by b, and I'm integrating 1 over x is len x. I substitute by b, and then minus the substitution of by the lower limit, 1. When I take b tends to infinity, I can use the table to see what is the behavior of lim b when b tends to infinity. Yeah, it goes to infinity. So it is infinite integral, this one. Okay. But the left hand side one, you almost going to go to 1. Okay. Now, what is the application of definite integral? As we normally say, the area is one of the application of definite integral. So what about if you have, you have infinite area, because it is open from the right here and it's open from above here. So the area is the integration of this function from 1 to positive infinity, the integration of 1 over root square x from 0 to 1, but I have a problem at 0, okay, because 1 over 0 is undefined. Let's go for the first one. This is the three types of the three formula